Geometry Unit 4, Lesson 9. I can solve for unknown sides of isosceles right triangles using special right triangles. So we're going to talk about what special right triangles are in just a moment. So if we take a look here, here's a regular quadrilateral, also known as a square, and the side lengths are going to be 3 each. So let's go ahead and get in there and do that. So we're going to say each of these is 3. Alright, and we want to now sketch one diagonal in there. And now I want to find its length using the Pythagorean theorem. So let me go ahead and take that over there. These are each 3. And I want to find this right here. Alright. Notice, however, that this diagonal comes in, and what did it do? It actually bisected the angles here in the corner. So this now is 45 and 45, 45 and 45. So I have a 45 here, and a 45 here, and a 90 degree there. This is called a 45-45 90 degree triangle. It's isosceles because the base angles and the legs are congruent. So let's go ahead and do the Pythagorean theorem. It's a squared plus b squared equals c squared. Don't forget your annotation here. That's going to be the c. So let's go ahead and leave that as maybe just x. And then we have 3 squared plus 3 squared from the legs. Let me zoom in so you can get a better look. Here we go. So that's going to give me 9 plus 9 for 18. I want to square root both sides to undo the squaring. And my x is equal to the square root of 18. But I can reduce that into the square root of 9 times 2, which is really just square root of 9 times square root of 2. And square root of 9 is 3. I don't know the square root of 2. 3 square root of 2 is the answer. Okay. So let's do the exact same thing again, but let's try it with side lengths of 4. All right, and if you want, you can pause this one and try it on your own. Here I go. These are all 4. I'm going to go ahead and sketch in my diagonal again. I can see that these are going to be 45 and 45. And then I'll just go ahead and re-sketch this triangle right here. And we're looking for x again. Same annotation. Across from the 90, that's going to be my longest side, or my c. And then I'm going to go straight at it. A squared plus b squared equals c squared. Here's my longest side. You get 4 squared plus 4 squared equals, call it x squared. 16 plus 16 equals x squared. 32 equals x squared. Square root both sides. And you get the square root of 32, which is really 16 times 2. So that's the square root of 16 times the square root of 2, which is really 4 square root of 2. So let's pause for a second. I can do this one down here in just a moment. But do we see a pattern? This came from a square, don't forget. And then it's 3, 3, 3 square root of 2. 4, 4, 4 square root of 2. So if we come down here and we do the exact same thing with 5, what do we think we might end up with? 5 all around. What would this be, do we think? And if you said 5 square root of 2, you're correct. So the relationship that we're going for here is that when you have, okay, a 45, 45, 90-degree triangle, which is isosceles because the base angles are the same, which means these sides must be the same. So if you call this x and x, what's this right here? Well, remember, this was like 5, 5, 5, square root of 2. So whatever x is, you put it right here, but then you put a square root of 2 next to it. That's the pattern that we just discovered from a bunch of examples up above. What kind of reasoning is that? Inductive reasoning. Because we came to a conclusion from a pattern. And that came from a bunch of examples. So I can't stress this enough. Take a look. You've got whatever the leg is, put it right there in front, but with a square root of 2 next to it. So let's go and actually do a few and see how you feel about it. So the pattern was x, x, x square root of 2. So I'm going to zoom in here, and the idea is to solve for the missing sides, and this is called a ghost triangle. I sketch a little smaller version of what's over here just to guide myself. So remember, this right here is going to be x, x, x square root of 2. So if I come over here, I see this is 45, which means this has to be 45 if all three of these will sum up to 180. So I have a 45, 45, 90 triangle. Don't forget, 45, 45, 90 triangle. That's a special right triangle. Again, here's the 45 and 45. X, x, x squared root of 2. So if this right here, if that right there happens to be a 6, then you know if this is 6 right here, I can put 6 right here. Again, whatever is here also goes there. It should also go here, but with what next to it? Square root of 2. 6, 6, 6 square root of 2. No problem. Let's go ahead and look at number 2. Look at the ghost triangle. I sketched it to match. If you remember, x, x, x square root of 2. So just take a look. Here is a 5. That's what goes right there. So that means if that 5 is right there and that's the x, and the square root of 2 is already there for both of them, then whatever that x is right here, it also goes here and here. So this 5 is going to go here and here. So I'm just going to put in a 5 and a 5. And I'm done. Now those are the easy versions, the basic. Let's go look at a proficient or hard level one. Here's number 3. Now there's no ghost triangle, so you want to sketch it yourself. X, x, x square root of 2. Now I don't see this side or this side, my legs. I do see I have a 45, so this has to be 45 as well to sum up to 180. But if you look at this 4 here, we have a problem, because I don't see a square root of 2. There's a square root of 2 over here, but not over here. So this is the hardest part, the hardest version, okay? If you take a look, this side right here is a 4. It's supposed to equal x squared root of 2. That's the relationship. So what you want to do is you want to go off to the side, and you actually want to write that out. Like, listen, 4 is supposed to equal x square root of 2. They're supposed to be the same. Let's go ahead and solve for x. How do you undo a square root of 2? Divide by square root of 2. It's being multiplied. Let's do it to both sides. This turns into 1, leaving just x. However, now you have 4 over square root of 2, and some people will be tempted to leave it like that. But you can't just leave a radical in the denominator, and this is why a week ago we spent time trying to rationalize the denominator. And I think you'll remember that we have to multiply by a 1, and in this case, square root of 2 over square root of 2. And if you do that, you get 4 square root of 2. Square root of 2 times square root of 2 I can actually rewrite as square root of 4. Square root of 4 is 2, and then you have 4 square root of 2 here. And then the 4 divided by 2 is just 2. And that's my final answer. We've done this move before, rationalizing the denominator. The setup is what's the key. Let's go try one more. You can hit pause and try it on your own. Okay, here I go. Ghost triangle. Here's my 45, 45, 90. So you have x, x, x square root of 2. How do you know where the square root of 2 goes again? It's always the longest side, so it's always going to be all the way across. And now what we want to do is realize that this 10 right here is supposed to equal x square root of 2. If there was only a square root of 2 right next to it, we would be fine, but there's not. So I'm going to go ahead and set up my equation. This time I'm going to write the x square root of 2 first. I'm going to go ahead and divide both sides by square root of 2. That turns into 1. Now you can't leave the square root in the denominator, so let's go ahead and multiply by our 1, which is whatever that square root is. So you have 10 square root of 2. I can't multiply those because they don't both have a square root. And then square root of 2 times square root of 2 is square root of 4. Square root of 4, I know. That's just 2. And then 10 divided by 2 is 5. Square root of 2 is still there. There you have it. Make sure you sketch your ghost triangle. Make sure you take a look and highlight for what you're looking for to make them set equal to each other. Solve and rationalize if necessary. Good luck.